All right. Chapter 6. This is, for me at least, where it starts getting a little too fun. Lots of, you know, of ratios and such we need to go over first. So there's for, let's say, suspensions, for emulsions, lotions, and such, there's a ratio of amount of a substance to maybe a different amount or volume of another substance, like we were talking about in chapter 5. So there's weight for weight, weight for volume, and so we'll things like that, and we'll go over more into this. But the questions for chapter 6 specifically are weight for volume. Might be some couple weight for weight. So let's look into that. We're gonna start with number 3. The formula for antifungal shampoo contains 2% weight for volume ketoconazole. How many grams of ketoconazole will be needed to prepare liters for the shampoo? So with these like something to something ratios, it's going to be the percentage over 100. So 22% weight for volume is 2 grams weight over 100 ml. So let's go ahead and start with that. So we'll write that down. How about that? 2%. 2 grams per 100 ml. Okay. So how many grams of ketoconazole would be needed to prepare 25 liters of the shampoo? Okay, so you see what another given is 25 liters, which you should automatically, depending on the question, but also look into it and see automatically know we have milliliters here, most likely are going to need this in milliliters as well. So just have that on bay. And they're asking for how many grams of ketoconazole based off of that ratio. So there's 2 different ways to go about it. The way that I like, again, is dimensional analysis. So we start with the number that we have, and then use our conversion factors, that bridge, to get what we need, right? Repeating a lot of the same thing, so it like really gets engraved in your head. So 25,000, we have that. We're looking for grams, right? And so we can go 25 ml, 2 grams per 100 ml. Ignore that if you heard it. 25K times, if you want to be specific, 2 divided by 100, you can 500. 500 grams of ketoconazole, also known as Nizoral. It's good for your scalp. If you have dandruff, it's really good. Another way to go by it is actually, for this type of question, I think proportions might be pretty convenient as well. You have this proportion right here, 2 grams per 100 ml. And you have your other ml, 25,000 here. So you need grams. 25,000 times 2 is 50,000, divided by 100. That's, might take 2 zeros off. That's also 500. 25,000 times 2 divided by 100 equals 500. Yep, sounds good. So that's that. That's our start. So think if your weight for volumes, weight for weights, all of these things as conversion factors. as your givens for your, well, it is a given as well, but it's your bridge for a lot of these questions. Okay, next one. We're gonna skip 6 because based off of that, it's pretty easy to calculate that by my understanding. 11. How many grams of sucrose must be added to 475 ml of water to make a 65% weight per weight solution? Okay, sounds like a lot. I know. And then you might, and some people might inherently think, okay, just 65 over 100, right? Multiply that. No, because you got to look at what we're looking over here, right? How many grams of sucrose must be added to this amount of water to make the ratio? So this isn't a combo of water and sucrose. This is just water by itself. So 65 over 100 is your ratio for sucrose. We need to know what the remaining ratio is for the water. So, I mean, if you do 100 minus 65, that's 35 over 100. So, hopefully you guys are understanding that. Like, these are two different factors over here, and we're trying to understand how much of each one do we need for the solution, right? It's not already like pre-made in, and then we're just calculating the rest. We're adding all these factors together now. So that's why. So we know that 65% generally is 65% of the drug over the total. So we know 65% over 100 is for the sucrose. And then 35 of 100 is for the water. So how do we go about this? We can do a percentage ratio. So think we know there's 475 ml for 35% of the, and then we want to calculate the amount of sucrose, which is 65%. So there's a proportion, right? So for this amount, there's that amount, and it goes to whatever amount you want to grow it to. So let's say 475. That is 35%. Okay. X is a 65%. Cool? Hopefully it is cool. So we do our proportions. 35 times X, and then 475 times 65. So we can do 475. Let's just do this. 475 times 65 divided by 35. So that is 882.14. 882.14 grams. Cool? Very cool. Another way to see this is dimensional analysis too. So what are we given? We have our 475 ml, right, of water. And then we want to go, so we know we know from earlier, 65% of the drug and then 35% of the water. So what we want is to switch that percentage now into percentage of sucrose, or yes, grams sucrose. So we multiply by 65% over 35%. That's basically the same thing of what we did with the proportions. And then we get our answer, 882.14. That could be ml, which is also equal to grams. Cool. Remember that you need to differentiate whether the values you're given are already part of a solution or if there are two factors that are being put together to make a solution. That's why we had to do all this extra subtraction and whatnot. All right, 15. Let's scroll down here. That's nasty. All right, let's give some space right here. Okay, let's read our prescription first, because understanding that may also help understanding where things go. So lactic acid, 4 grams, salicylic acid, 5 grams, trichloroacetic acid, 2 grams, flexible collodion, quantity sufficient as directed. So we don't actually just yet know how much collodion was used. But after that, it says for a total of 100 grams. So when like reading this and saying the quantity is sufficient, you know it's not going to be 100 grams. If you're thinking, right? Because they say quantity sufficient, so they're not telling you exactly how much is needed. But if there's 100 grams right next to it, you need to infer that, okay, that's probably the total for with everything combined. So that's going to be important for our questions going on. So 15A, flexible collodion contains 20% weight-to-weight camphor and 30% weight-to-weight castor oil. How many grams of each would be contained in 30 grams of the mixture? So that's going to be, a lot of work. Let's start right here. So they're specifically looking for flexible collodion and its contents. So we need to find out how much flexible collodion there is actually. And so we know the total is 100 grams, and we aren't working with specific gravity or anything, so it's just simply subtraction. 100 minus 2, 98 minus 5 is 93, 93 minus 4 is 89. 98, 93, 89. So that's 89 grams of collodion. And so now we know how much collodion there actually is. And now we have our ratios for camphor and castor oil, so we can check how much there is in what we have so far. So for camphor, 89 grams times 20% weight to weight is 20 grams over 100 grams. Equals 89 times 20 divided by 100. 17.8. Okay. Ooh. And then we can do 89 times 30 divided by 100. 26.7. So 89 times 30 over 100, 26.7. So 20% that goes for camphor. And then 26.7, that's 30% of castor oil. All right. And then, so that's just for what we have total, right? We need to make sure that we're um, looking for 30 grams of, let's see, what is it saying? Grams will be containing 30 grams of the mixture. So 30 grams of the mixture. This is why comprehension is very important and it's very specific, unfortunately. Even we are looking at collodion specifically, but when we're converting this into 30 grams of the mixture, you want to think what we had from the beginning, which was 100 grams. So if we're looking for how many grams of each, we have these grams per the 89 grams of collodion, and therefore of the total mixture, which was 100 grams. So we can say for camphor, 17.8 over 100 grams of the mixture equals how many grams for 30 grams of the mixture? X equals 17.8 times 30 divided by 100, 5.34. Grams of camphor. And then same goes for, let me wipe this off. Pause if you need as you go, working out the answers here. 6.7. For our castor oil, 26.7 over 100 of the mixture equals how many grams for 30 grams of the mixture? 6.7 times 30 divided by 100, 801. So that was just one part. Let's go with B. Keep that. The specific gravity of castor oil is 0.955. So let's actually write that down first. Specific gravity 0.955. How many milliliters of the castor oil are contained in 30 grams of the mixture? So we had from previously our numbers for camphor and castor oil. So that's castor oil right here, 8.001 grams. Grams castor oil in 30 grams mixture. Thankfully, we had that, so we don't have to redo the problem, right? So how many milliliters of the oil are contained in 30 grams of the mixture? We can use our specific gravity pyramid again. So we're given 8.1 grams, and we're looking for milliliters of the oil, which is equal to the same volume in H2O, which is converted into grams. So we can do, that's what that is. That's what we're looking for. So we are given our amount in grams divided by over our specific gravity, 0.955. 8.39 ml. Let's see how our little pyramid comes in handy. Very cool. All right. Let's go ahead with C. If the specific gravity of the mixture is 0.781, what are the weight to volume concentrations of lactic acid, salicylic acid, and trichloroacetic acid in the mixture? Okay, so weight per volume. Lactic acid, let's see. Okay, so we're looking at specific gravity of the whole mixture now, because that includes all these components now. That's why we're able to look at the weight to volume concentrations of lactic acid, salicylic, trichloroacetic, all these components. And so we need to find, we need to start with the what the volume is, what the total volume is of this whole mixture, because specific gravity is what? Grams of a substance over grams of H2O equal to the volume of that other of the mixture, substance, whatnot. So we'll start with that. So SPGR H2O G, right? What are those? So we can do 4 over, let's start with lactic acid. So lactic acid is 4 over 781. Sorry, I think it's 100 over 781. Yeah. So so we're looking for the volume of our mixture. We have grams of the mixture, right? And we have our specific gravity of the mixture. So that's how we start. 100 milligrams, 100 grams, sorry, divided by 781 equals 100 divided by 0.781, 128.04. Let's just say 04 ml. Okay, so that's our volume of the mixture, total volume. So the question itself is asking for weight to volume. Remember, we need to remember that weight to volume is grams of a substance over 100 ml, or the volume of the standard substance. So we have our volume now of the actual volume of the mixture. We need to find the proportionally equal amount of drug for 100 mLs of the mixture. That's what weight to volume is. So that's proportions, like I said. That's how we go about this. So we now know that there's 4 grams of lactic acid in 128.04 ml of our mixture. So what is the weight to volume concentrations? We know that weight to volume is something over 100 ml. So we just need to solve for x. So that becomes let's clear that up. 100 times 4 divided by 128.04. So for lactic acid, it's 3.12 grams per 100 ml. So that's basically weight to volume, 3.12 grams per 100, or 3.12% weight to volume. That's the equivalent for that. So we have that. We can do that for salicylic acid, 5. Same thing. 100 times 5 divided by 128.04. 3.91 grams of salicylic acid. And now last one, 2. Here's a trick. So with calculators, you can actually go up. You enter, and it copies the same equation that you put in, and you can edit. You can press delete here, and then second insert 2. Instead of retyping the whole equation again. So that's 1.56 grams of trichloroacetic acid. So a lot of thought going into this, but at least, like, hopefully you're understanding like where we're coming from, right? If they're asking specifically for something like percentage weights of one ingredient within a mixture, you want to subtract everything out first from the mixture, isolate the ingredient that we're looking for, and then do the proportions and such. And then see, then wording is very important too, specific gravity of the mixture. So we had to go back to the full amount of 100 grams, and go from there. It's quite a bit, lots of practice. Again, pyramid is very important to go by, and take your time to think. I know, like, train your mind to see what we're trying to, what component we're looking at, mixture or individual, and then take your time to work it out, make a process to make it work out. Okay. Last but not least, 22. Ah, okay. If a city water supply has a limit of 250 parts per million of nitrate ion, what is the maximum amount of nitrate ion in grams that may be present in a 10,000 gallon reservoir? So, parts per million, parts of a million. So, 250 ppm is equal to 250 grams of nitrate ion. That's what nitrate ion looks like per 1 million ml of what's water, I guess. It's a water supply, right? City water supply. And they're looking for the maximum amount of nitrate ion in a 10,000 gallon reservoir. Okay, so we're giving our conversion factor. We have our given 10,000 gallon reservoir of water, so we know it's water, right? So they're asking the maximum amount of nitrate ion in grams. Okay, so we can't go directly from gallon to ml like that, right? We need to convert it into ml and then cross that out. So this is by this setup, up to you how you go about it, but dimensional analysis looks good. So we can say 10,000 gallons times 128. These are known values you need to know per gallon times 29.57 ml per ounce. So we have cross out gallon, cross out ounce. We now are in ml range. So now we can use our conversion factor to get grams of nitrate. 1 million ml. That equals, it's a big one. Okay. So let's do this. We can do, either way is fine. It doesn't really matter. 10,000 times 128 times 29.57 times 250 divided by 1 million, 10 to the 6, doesn't matter, however you want to write it. Okay. Answer is 9,462.4 grams. That looks pretty big, so let's double check here. And that's correct. Of nitrate ion. So the goal of that was just to introduce you guys into parts per million. It's pretty, self-explanatory what that means. 250 parts of a million. All right, that sums up chapter 6 and module 1 in that case. Don't forget to like, comment, and subscribe, and follow us in our next module, module B. Peace.